drawing structures and naming structures by replacing hydrogens on an alkane chain with things from table R. Now, I just want to point out on table R, okay, there's a lot of help here because it shows you what is added on. So R represents a carbon in the parent chain. And so this is whatever is there. That's what we're replacing a hydrogen with on that carbon. And when it comes to the names, we have example names. So whenever you're going to name an alcohol, take a look at the example name in table R, and your example needs to look just, or your name, use this as your model. So here we go. We're going to start with halocarbons. When we replace one or more hydrogens on the parent chain with a group 17. Okay, so we're going to start off with our first simple alkane. Okay, so here we go. We have a carbon and it has 4 hydrogens added to it. And because this is a straight up hydrocarbon, we would call this methane. And what we're going to do is we're going to put this methane through a substitution reaction. So substitution means we're going to remove one or more hydrogens and replace it with a halogen. So I'm just going to use fluorine, so substitute reaction. So here we go. So this one hydrogen, it gets swapped out, right, with one of the fluorines in the fluorine molecule. So here we go. So when we go to draw this, we still have the only carbon. It still has the 3 hydrogens attached to it. And now the 4th hydrogen has been substituted with a fluorine. So here's the thing. This structure, it can no longer be referred to as methane. So when we take a look at this, okay, we're going to start back at the beginning. We take a look at the longest continuous chain of carbons, the parent chain, okay, match that n number of carbons to table P to get the prefix. So when we take a look at this, we still only have 1 carbon, that's the PC, so it is still meth. Now, this carbon is not double or triple bonded to any other carbons, so we use the ending ane. But if we leave the name like this, then it has the exact same name, but the structures are different. So when we go back and take a look at table R, okay, take a look. In this example here, we see the parent chain name, propane, but out in front of it, we are identified with the halide. So chloro means that they added Cl to it, but I added F, so out in front of the word methane, I would put the word fluoro. So coming out in front of this, okay, I just write fluoro methane. Now, to this structure, I'm going to put this fluoromethane, the methane part of this structure, I'm going to put it through another substitution reaction. And once again, I'm going to replace one of the remaining hydrogens with a fluorine from a fluorine molecule. So like before, one of the fluorine atoms is going to come in and kick one of the remaining hydrogens out. So when I go to draw the structure, I have my original carbon. I still have 2 of the original hydrogens. I also have the original fluorine that was placed on the parent chain. And now I have the second fluorine. So, like the previous example, okay, here is my parent chain. It's still a 1 carbon parent chain, so it is still meth because there is no double or triple bond of this carbon in the parent chain to another carbon. We use the ending ane. We still have the original fluorine added, so I put that out front, fluoro. Oops, I wanted to make that black. But if I leave it like this, it looks like the first substitution reaction. So that means the name is not done. This structure looks different than the first substitution. So it has to have a different name. Well, I added another fluorine atom to the parent chain. So I have to put that in the name also. So I have to put fluoro. So this is fluorofluoromethane. Now, take a look. This is a mouthful to say, so of course there is a way to shorten that. So we're going to take a look at rule number 7. So if one or more halides of the same type, so they both are the fluorines, are added that to that carbon chain, instead of saying fluorofluoromethane, we replace one of the fluoros with a prefix. So di means 2, tri means we put 3 of them, tetra means 4. So this name would get reduced down to difluoromethane. That would be the final name here.